these are notes for dilutions and the notes for the rest of the solution packet. So dilution, we decrease the concentration of a solution by adding more solvent if we want to dilute something. Chemists spend time diluting stock solutions of acids when preparing for labs. Stock solutions of acids come at these concentrations. Sulfuric acid is 18 molar, nitric acid 16 molar, hydrochloric acid is 12 molar. So when you dilute, make sure that you remember the number of moles before are exactly the same as the moles afterwards. You still have the same amount of stuff in there according to moles, even though the solution part may have changed. The ratio to solvent or concentration of moles changes. So if a solution is diluted, the molarity decreases. The key to doing these problems is that only water is added to dilute a stock solution. Always a before and after problem. So M1V1 equals M2V2. That means the molarity 1 is before, the molarity 2 is after, the volume 1 is the volume before, volume 2 is actually the total volume of solution after. Let's do problem number 1A from worksheet 4. Calculate the new molarity that results when 250 milliliters of water is added to 125 milliliters of 0.251 molar HCl. Let's grab the pen. And in these kind of problems, I like to write down what I know. So I'm going to write down what I know, calculate the new molarity. So new molarity must be M2. I'm trying to find what that is. That results when 250 milliliters of water, so that's a volume, is added to 125 milliliters of 0.251 molar HCl. So I'm not sure about my volume yet, but I know my original molarity is 0.251 molar. So I'm adding this to this, so this must have been the original. So V1 must be 125 milliliters, which means V2 must be the addition of those two, which is 375 milliliters. Let's hope that's what it is. Now, I'm going to use the equation M1V1 equals M2V2. And in college, they'd like you to isolate your variable before doing the plug-in of the numbers. So that's the one I want. I'm going to put it on this side, which means we still have M1 and V1 on top, and the V2 has to go to the bottom. Now we just plug and chug our numbers. So M1 is 0.251 molar. And we're going to multiply it by volume, which is 125 milliliters. And the second volume is 375 milliliters. And are you asking yet, why are you using milliliters, Miss A? I'm using milliliters because they cancel out. You could have used liters, and it would have worked out fine, but this time I saved myself some work by not changing. It's just when you're using one M and one V that you have to use liters. So the second molarity, after you multiply and divide, is going to be 0.0837 molar. The end of the story. Ta-da! So now we're going to do stoichiometry. It's all coming back for fun. So make sure you balance your equation. Make sure you find moles by either doing grams to moles, or perhaps you need to do molarity times volume, which is liters. You might need to find a limiting reactant. Oh no. You'll need to use the mole ratio to go from what you're given to what you want. And you'll need to answer the question, which is if you find grams, you'll change moles into grams. Or if you're trying to find volume, you'll do the moles divided by molarity. Or if you're trying to find molarity, you'll take the moles you have and divide it by the volume. So let's do it. This is problem number 4 from worksheet number 4. So how many grams, let's grab a pen here, how many grams of PbI2, I'm going to put that there, are formed when 500 mils, here we go right here, we can't have milliliters in this, I know this already, so I'm going to move the decimal 1, 2, 3 times to the left, 0.500 liters of 0.550 molar Ki reacts with excess lead nitrate. So I'm here and I'm trying to go there. It's definitely stoichiometry. So is the equation balanced? 1 Pb, 1 Pb. 2 NO3s, nope. Here we go, 2 NO3s. 1 Ki, 2 Ks, put a 2 there, 2 I's, yay, we're balanced. So the first step is we're going to multiply those two together to get ourselves moles. So let's do it. So one is going to be molarity times liters to give us moles. And so we're going to go 0.550 moles per liter times 0.500 liters. And that's going to get us 0.275, there's a 7 there, moles of Ki. Now the question says change to grams. We can do that. Oh, well, we have to find the mole ratio first, so we'll go 0.275 moles of Ki, and we'll do the mole ratio. There's 2 moles of Ki. I got the 2 right from here for 1 mole of PbI2. It's a 1:2 ratio, or if you looked at it the other way, it's a 2:1 ratio. And then we just need to change to grams. 1 mole of PbI2 has a certain mass, and it is a ginormous mass, 461.0 grams for PbI2. They're really heavy elements. And we do a little math. 0.275 divided by 2 times 461 gives us about 63.4 grams of PbI2. We did stoichiometry. That was fun. I got stoiched doing stoichiometry. Another Stoich problem. This is worksheet 4, number 7. This looks like it's going to be a fun one. What does it say? It says find the volume in liters. So I'm going to write that. Find the volume in liters of NO gas at STP. Oh, this is going to be beautiful. At STP, if you have 1.75 liters of this HNO3. So we have 1.75 liters, and the molarity is this 0.550 molars. And excess, so what it means is we don't care about the excess. So we're trying to go from there to there. So we're going to multiply those two things together, the molarity times the liters, to get us moles. And if we multiply those two things together, we're going to get 0.96. I'm going to carry out a few extra digits in this, moles of HNO3. Now my second step is the mole ratio. I'm going to rewrite this number, 0.9625 moles HNO3. The mole ratio is it a balanced equation? It is not. We need 2, we need 3, we need 2, we need 3, and we need 4. That was a wicked one. So there are 2 moles of HNO3 for 2 moles of NO. Oh, it's a 1:1 ratio. That's a beautiful thing. So that's the same number, 0.9625 moles of NO. Now the question says find the volume. Oh, golly, at STP. Oh, we can do this. We know nothing else, so 1 mole of any gas at STP, and this one's NO, is 22.4 liters. That comes from the previous chapter. So we multiply those two together. We can have only 3 sig figs. That gives us about 21.6 liters. That's a 6 of NO. Stoichiometry is so much fun. Let's finish up the notes. Let's go like a fast speed skater. So properties of a solution. Physical properties are divided into 2 categories. Extensive properties, which depend on the size of the sample, and intensive properties that do not depend on the sample size, or they depend upon things such as density, concentration, temperature, color, melting point, etc. Colligative properties fit into the intensive property category. They only apply to solutions, and the number of solute particles present affects the properties of the solution. So this leads us to boiling point elevation and freezing point depression. So boiling point elevation. Adding more solute particles will increase the temperature at which the substance boils. For example, salt in pasta water. Why does this happen? The solute and solvent particles are attracted to one another such that it would take more heat energy to boil the solution. Freezing point depression. You can lower the temperature at which something freezes by adding solute particles. It's useful on the roads in the winters. Why? It will allow snow, if it's falling, to melt to a lower temperature than it normally would at the regular freezing point. The end of our notes for solution.